We're going to go ahead and finish our discussion with on geometry with areas, and then we're going to deal with some circles and volumes. But first, all of these formulas should make sense. The area of a rectangle being base times height. If I had let's just say a rectangle that was 5 units, 1, 2, 3, 4, 5 units wide and 3 units tall, then basically if I were to cut this up 5 units tall, wide and 3 units tall, I could count the number of squares in there. It'd be 5 by 3 or 15 units. The area is not the space outside, it's not the distance outside, that's perimeter. The area is a measurement of the space inside the object. Okay? So to get the area of a rectangle, we just multiply that base times height. If it's a square, it's actually a little easier. As square, once again, all 4 sides are the same. Then basically the base and the height are the same, so side times side or side squared, which is once again why we call things that are squared a perfect square. A triangle, a way of thinking about a triangle is actually very easy. If I were to take that same rectangle I did before, I could create this triangle by cutting that rectangle in half. So if I took this rectangle and I were to draw a line, say right across it, I would form that triangle. By what? Taking the area and just doing half of it. That's not really a new idea, it's just any triangle will be half of a rectangle. I'll come to the other ones down here in a second, but they are the same formula. For a parallelogram, it's just base times height. Well, why? I don't know. Well, why can we do that? Well, basically, the way of thinking about it is I could take this triangle right here, and if I just did base times height, basically I could relocate the triangle over here, and it would perfectly fit over here to the right. And then what would we have? We would have a rectangle that is just what? Base times height. So the area of a parallelogram and the area of a rectangle are the same because any parallelogram can be turned into a rectangle. The area of a triangle is always half of that because, well, this first triangle is half of the rectangle. The other two are not half of that rectangle, but if I were to double them, I would get a parallelogram, which is the same as a rectangle. So any triangle will be either half of a rectangle or half of a parallelogram. So either way, any area of any triangle will be 1/2 of the base times height. Keep in mind the height that we measure is at a 90-degree angle from the base. I need it to go straight up from that distance for it to be the height. Some easy examples. Here I have a rectangle that is 4 by 3. The picture looks horrible, but we'll say 4 by 3, so it's 3 wide by 4 tall. How many square units would be in there? Well, length times width, base times height, 3 times 4, we would have 12 square units in there. Well, what if I took that and I cut it in half and turned it into a triangle? Well, it would now be 1/2, 3 times 4, or 4 by 3. All this is that rectangle cut in half. We already know the 4 times 3 is 12, so half of 12 would be 6 square units. What if it was a parallelogram that was 4 by 3? Well, I could move this triangle over here, fill it in, and now it would just be a rectangle that's 4 by 3, or still 12 units. Rectangles and parallelograms have the same area. A triangle is always half of that. What if the triangle got a little funky? Well, you have to figure out what the base is. I still have my formula. It's 1/2 base times height. The height, I always see from the 90-degree angle. Straight up from there is the 3. So then what must our base be? Right? This 5 right here is at a slant. We are not using that. This 10 is at a slant. We're not using that. I need the flat base, which this time is the 7. The 7 is the base, the 3 is the height. So my area is 1/2 7 times 3, or as a decimal, 10.5 units squared. Well, this time we have inches, so square inches. Okay? This one is a parallelogram. So the area is not 1/2, just base times height. Well, what's the base? Easier to find the height. Find the 90-degree angle. And from there, we have our height. They've slanted it and tried to mess with this, but basically think about this kind of falling over. The 12 would be the base, and the 2 would be the height. So it is base 12 centimeters times height 2 centimeters. The area would be 24 centimeters times centimeters, or square centimeters. What if the numbers are complicated? Then we give up? No. The area is just what? Base times height. I'm not putting those numbers in my calculator that way. I need to turn them into improper fractions. 28 plus 1, how about 29 over 4 times 6 plus 1, 7 over 2. So 29 over 4 times 7 over 2. Or as a fraction. 203 over 8. Probably not very useful. How about we keep it as 25.375? Square feet. If I'm dealing with a circle, we have the area, which is still the space inside, and the relationship with that is pi r squared. The circumference is the distance outside, so think like the perimeter of the circle. But I can't add all of the sides because it just has one long side, and the relationship is 2 pi r. Or if I take the radius and I double it, if I do 2 radii, I take the radius and I double it, I get what is called the diameter. So I can also call this formula pi times d. These are generally the two formulas I use, but there's nothing wrong with pi times diameter. I just like both of these because they both have a 2, a pi, and an r. For the area, the r is being squared, so that's where the 2 goes. Here, the 2 is being multiplied in the front. Okay, so for this circle, the radius is the smaller from the center to the outside, and the diameter is equal to 2 times the radius. So 2 radii add up to the diameter. Find the approximate area and circumference for a circle with a radius of 5 feet. Well, the area is pi times r squared, or pi times 5 squared. For pi, they'll tell you to use approximately 3.14. That's not an exact number, that's just an approximation. So I can do pi 3.14 times 5 squared, and that would be the answer they would want you to write down. It has an approximate area of, I lost it, 75, I think. 78.5 square feet. Now, if I wanted that more exact, then I would use a pi button, and I would actually use, let's see for me, here's my pi button. Pi times 5 squared. And that is, well, there we go. a little more exact, 78.5398. They're going to be fine with this for now. The circumference, 2 pi r, or 2 times pi times 5, or 2 times 3.14 times 5. And they'll be fine with 31.4. Notice this is not feet squared. This is the distance if I were to walk on the outside of the circle, not the space inside the circle. Find the approximate area and circumference with a circle with a diameter of 15 feet. Well, the area is pi r squared. They did not give me the radius. They gave me the diameter is 15. So if the diameter is 15, here's my circle. If all the way across is 15 units, then what is the radius from the center to the outside? Well, it's half of that. So half of 15, 7.5. That would be our radius. So 3.14 times 7.5 squared. 3.14 times 7.5 squared. 176.625 feet squared. Circumference 2 pi r, 2 pi times 7.5. You could do 15 times pi. It would give you the same answer. 2 times 3.14 times 7.5. 47.1. 47.1 feet. Next, we're going to talk about volume. The volume is not just like the area space inside. Volume is still space inside, but this is basically the space inside a 3D object. We're not figuring out how many squares we can fit in here. We are figuring out how many cubic units we can fit inside this object. There's a really easy general approach to this. The volume of any prism is the area of the base times the height of the prism. So, if it's a triangular prism, the base is a triangle. So the area of the base would be 1/2 length times width times the height of the prism, h. If it's a rectangular prism, then the base is this rectangle, which has an area of length times width times the height of the prism. Notice it doesn't make sense to call this base height and height, so I get that that's a little confusing, but when I deal with a prism or a three-dimensional object, the height has to be what is basically coming off of the surface there. The volume of a spherical prism, or we call it a cylinder. Well, the base this time is a circle. It's the area of a circle. Times the height of the prism. So all three of these basically have the same formula. It's just the area, and when I multiply it times the height, it doesn't tell me how many squares fit in there. It would tell me how many cubes it would take to fill that object. Find the volume of the triangular prism. Now they've tried to mess with us here because they rotated it, but basically think about the triangle as our base. Okay? So I've got this triangle, and it is our base. What is the area of that base? 1/2 length times width times the height of the prism. So if we set it up, the height would now be 10. 1/2, 8 times 6 times 10. Half of 8 is 4. 4 times 6 is 24. 24 times 10, about 240 cubic feet. It would take 240 cubes to fill this object. What if it's a cylinder? The area of the base this time is a circle, so pi times r squared times the height of the prism. So 3.14 times 2 squared times 8, I'm not doing that one in my head. 3.14 times 2 squared times the height of the prism, 8, about 100.48. Cubic centimeters to fill that object. Here we have a rectangular prism. The numbers are a little more complicated. The formula is still the same. Just length times width times height. The length, 4 1/3, times the width, 3 1/2, times the height of the prism, 2. I'm not going to leave these like this when I put them into my calculator. I need 4 times 3 plus 1 would be 13 over 3 times 3 times 2 plus 1, 7 over 2 times 2, 13 over 3, 7 over 2. How about 13 over 3 times 7 over 2 times 2. If I wanted that as a fraction, (91/3). Not as useful. 30 1/3 I'd be okay with. Or 30.3, rounding it off, cubic inches. We also have the volume of a sphere. This is something that they'll give to you and just expect you to be able to operate the formula. Well, if I have a sphere with a radius of 5 and the volume is 4/3 pi r cubed, well then it would become what? 4/3 pi times the radius 5 cubed. 4/3 pi, which is 3.14 times the radius 5 raised to the third. If you don't have a raised to the third or you don't know how to do that, you could do 5 times 5 times 5 to get that 5 cubed. So how about 523.33 cubic feet. Our last little thing that we're going to do with geometry is we're going to do some indirect measuring. This relates to what we did before when we had the similar objects, but basically an indirect measure is where we have naturally occurring similar triangles, and if we have similar triangles, that means the sides are proportional. This occurs in nature. Here's a really easy example. If you were to look into a mirror, you would end up with a similar triangle. So if I can stand, here's Lena, she's standing, she's looking down, here's a mirror right here. Right at that mirror, she can see the top of the tree. Then basically from her eyes to that mirror, she's created this relationship where there are two similar triangles. You can measure the height of the tree without actually measuring the tree. The mirror is 31 feet from the tree. Lena is standing 8.2 feet from the mirror. Her eyes are 5 feet above the ground. How tall is the tree? Well, what's the ratio of the sides? Well, 5 over the height of the tree, h, is equal to 8.2 over the 31. We can solve for the height of the tree. I'm going to multiply both sides by both an h and a 31 to cancel out these fractions. So 31 times 5, how about 155, is equal to 8.2 times h. I can now solve for the height of the tree. 155 divided by 8.2. It's about 18.9 feet tall. So that's one way you can actually measure any object if you place a mirror and where you can see far enough and you can get it to actually barely see the tip of the object, you can measure the height. Here's another example that I like that shows up in real life. You are 5 feet 8 inches tall and you're casting a 3-foot shadow. How tall is a building that is casting a shadow of 32 feet? Well, here's the problem. Here's your height. There you are. Okay. Here you are. There we go. So you are 5 feet 8 inches. And your shadow is 3 feet. Well, there's a triangle right there. Okay. Here's a building that is way taller than you, and it has a 32-foot shadow. And if that's occurring at the same exact moment, then you can actually say there is a relationship that of similar triangles, because the sunlight will create the same angles, will create the same triangles for any object depending on the shadow there. Okay? So I can set up a ratio. The problem is I've got feet, 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 and inches. So I need these all to be the same measurements. Okay? So what might be easier in this situation, if you don't want to deal with a fraction, is to turn all of these into inches. You need to know that 12 inches is 1 foot. So that 3 feet would be what? Well, 3 feet times 12 inches over 1 foot. 3 feet would be 36 inches. 5 feet would be 5 feet times 12 inches in 1 foot. That would be 60 inches. So 60 plus the other 8, you are 68 inches tall. Now this 32-foot shadow is a little trickier, but I got to do 32 feet times 12 inches over 1 foot. 32 times 12 would be 320 plus 64, so about 384 inches. So now I can set up the ratios and go, your height, I'm going to actually do it back. The height of the building over your height is equal to the length of the shadow over your shadow. And I can now solve for the height of the building. I set up a ratio of similar sides. This height to this height over this shadow to this shadow. And I could set up the ratio either way. I just like this better because the height's on the top. So to solve for h, I'm going to multiply both sides by, so that the height of the building is 384 over 36 times 68. $384 over 36 times 68. 725.333 inches. If I wanted that in feet, and I don't really, but if I wanted to, I could then take that and multiply it by 1 foot over 12 inches so that the inches will cancel. And so I would basically just divide that by 12, which is actually our next section. So this is a little more advanced, but I wanted you to see how this would work. So it's about 60.444 feet. And I'd be fine with either of those at this point. So I know there's a lot to the geometry. Let's keep working through it. And then we have really one more section before we really get into the algebra and do our Math 55 sections. So keep it up.